All right, so we're going to find volume about x equals 2, a non-axis, okay? We're going to do two methods. I'll do it, all right? We'll do cylindrical shell second. We will just do volume and see what kind of shape this is first. And we're going to draw the region. I need a picture. This is one of our mother functions here, square root of x. It's shifted 3 to the right. So here's our mother function. And that's x equals 7. Y equals the square root of x minus 3. And y equals 0. So our region is right here. I probably won't leave it shaded because it gets a little confusing if we shade it. So there's our 3 lines. We got our region. And we're going to rotate it about x equals 2. We have two methods. We either go from a to b of ay dy, all right, because that's perpendicular to the axis, and the thickness here is, I always joke the thickness is dy, or this is, we're going to do it secondly by cylindrical shells, all right, which is the circumference times the height dx, all right. We'll do that second, all right. But I will tell you that this comes with some difficulty. So we'll make this small. We'll just store this up here for a second. So I'm going to stick with this method. And when we rotate this, hopefully you guys see that this is going to be a washer. When you rotate this shape around, there's going to be an RI and an RO. Okay? Now I'm going to draw it up because every time we do this, we're going to have this. I'm going to get rid of this black line. So when I draw the shape here, moving my way down the board, my AY, my cross-sectional area here, is a washer. With some sort of outside radius, some inside radius, RO and RI. And we know the area of this up here. It is pi RO squared minus pi RI squared dy. And I'm going to put the limits of integration in right now. It is 0. I plug 7 into my function up here. 7 minus 3 is 4, square root of 4 is 2. So my limits of integration are 0 to 2. All right, for this one. And I really don't want the extra stuff, so I'm going to get rid of it. So I'll pull that out. And we have to use those because we're going in the dy direction. And again, the question simply becomes, what is RO and RI? And we can't leave those in there, right? Because they're not in terms of Y. So my big problem here is when I look at this graph, my RO is actually pretty easy. What's the distance from 2 to 7? 5, right? My RO is always 5. That's 5 squared. All right? Or you could say, right, 7 minus 2. Does everybody agree with that? My RI here, my distance from, and if I do this in purple, my RI is a lot more difficult. That's RI. Remember, I know right now that I'm going to have to solve this for x. So, not to get caught into a lot of algebra, but I'll just show real fast how you square both sides, right? And x equals y squared plus 3, right? We all agree? So this distance is some x distance, but it's not x to that point. It's x minus 2. So I'm going to leave this second one as y squared plus 3, that's x, minus 2. And everybody, this would be a problem I could easily integrate, do we agree? I mean, I'd probably square it out and do a bunch of work. All right, but that would give me a solution. I also could type this into my TI calculator and get an answer. So I'm going to pause and do that. So everybody, I put it in my calculator. I tell my fraction to go to my decimal to go to a fraction, and I get it's 544 over 15 pi. That's my volume. So no matter that, we are done. If this is a test thing, we can just stop. Now what I want to do is this same problem using cylindrical shells. So I want to take 1 second here and maybe go entire page and box up all this stuff. Alright? So I'll pause and we'll get rid of all this so when the video starts again it'll be a white screen. So we save the volume, we'll bring the equation back down. Our equation is that's the circumference, right? Now cylindrical shells is a whole different idea. We are going to add up a cylindrical shell, right? And it is going to be here. And obviously the height of this shell is the function. That is f of x. That is the height of this cylindrical shell. Now the problem here is the radius is not x this time. The radius is not x. X would be this distance. That's not my center, is it? Y-axis. My center is the green line. So it's not x this time for a radius. It's x minus 2. Because this would be the whole x distance, and I want it to be this distance. So when I set this up, and this is why you really want to understand cylindrical shells, because if I get rid of that shape, literally, I draw this line here, boom, and I say to myself, okay, I'm going to rotate that, since it's a circle, right, it has to be a cylindrical shell, since I can do it as a cylindrical shell, I can add those up, that is dx thick, so here I go 2 pi, and now my x's are easy, 3 to 7, I don't have to worry about figuring them out. It's not x, but it's x minus 2, and it's square root of x minus 3 dx. And again, if I said set up but do not evaluate, we are done. And again, I suppose the double check is we want to put it in our calculator and make sure it's exactly the same answer. Let's pause it again, keep the video short for our guests. And a quick check of the calculator, the decimal is exactly the same. The volume is that, or for 4 decimal places like the AP, they were both exactly this, 4 decimal places deep, 2.2667 for volume. I will say on the cylindrical shell method, I wasn't able to convert to a fraction because of some calculator error at the 10th decimal place. Not really going to care. We can do it either way. I think the cleaner way to do this problem is with cylindrical shells.